more polynomial function practice. Example 1. Add the polynomials. All right. So the title is More Polynomial Function Practice. So I've been throwing a lot at you this week. I'm going to pause and just do some more practice problems. I'm not going to cover anything new. Just want to review a little bit what I covered. Let's add the polynomials. Watch. Let me write two polynomials. X to the fourth minus 3x squared plus 2. That's a polynomial. Plus 7x to the fourth minus 8x squared minus 8. Oh, yikes. All right, if we're going to add polynomials, I got a trinomial with another trinomial. All I'm going to do is add like terms. I'm going to color code like terms. I'm going to underline the x to the fourth terms in green. I'm going to underline the x to the second powers in red. And I'll underline the constants, the numbers without a variable. We call those constants in black. Talk to me. Sure, absolutely. Sure. You're welcome. So I'm going to add like terms. I color coded the like terms. Here we go. Ellen, Gabriel. X to the fourth plus 7x to the fourth I can combine by combining the coefficients. The coefficient for x to the fourth here is a 1 because it's not written, so it's automatically a 1. So I got 1 plus a 7, I got 8x to the fourth. That was easy. I like to cross them out once I'm done. You don't have to, but that's what I do. Now the coefficients for the x squared terms. Negative 3x squared plus a negative 8x squared. I got a negative 3 coefficient plus a negative 8 coefficient. That makes a negative 11 coefficient. X squared. I'll cross them out. You got this, Gabriel. You're balling, you're balling. Last but not least, I'm going to add the numbers with numbers. 2 plus a negative 8, I want to say is negative 6 and my coffee is kicked in. Here's our final expression, the trinomial. It's colorful because I color coded it. Before I go into example 2, any questions on example 1? That's adding polynomials. But we also covered subtracting polynomials, which is what I'm going to do on example 2. I'm going to take the exact same polynomials. X to the fourth minus 3x squared plus 2 minus the second polynomial. Okay, I'm writing the same polynomial, now I'm just going to subtract them. Same polynomials, but instead of adding, I'm going to subtract these puppies. Does anybody remember what I do when I subtract polynomials? There's a slight move. I have to do something slightly before I actually subtract them. I got to do something when I subtract. I got to distribute something. Does anybody remember from Monday's notes, the video notes? What do I distribute? What do I spread when I subtract? I have to spread something. Going once, going twice. spread something. Hit it, Alan. Save the day. Close. Sorta. I like it though.
You're very good.
Give me more. Beltran, hit it. I know you know it.
Is it the subtraction symbol?
A little more, it's the subtraction symbol. There's actually a -1 there. And what I gotta spread, when I say distribute is just a fancy schmancy word, Guzman. It's a fancy schmancy word meaning to spread. I'm gonna spread a -1 to every term in that second polynomial. In other words, the polynomial that's being subtracted, I'm gonna spread a -1 everywhere. And then I'm gonna combine like terms. Watch. See, multiplying by -1, you should have covered in junior high and in Math 1. If you forgot, I got some videos that can help you refresh your negative and positive number stuff. But talk to me later about that. -1 times a +7 is a -7x squared. Look at every x to the fourth rather. Everything turns its opposite. What was once a +7x to the fourth becomes a -7x to the fourth. What was once a -8x squared becomes +8x squared because I'm multiplying by -1. And what was once a -8 now becomes a +8. Now I combine like terms. All right, all the x to the fourths, all underlined in red. All the x squares are underlined in blue this time. And then the numbers are underlined in green. So the key here, when you subtract polynomials, you have to distribute the -1 first. And now I'm going to add. So now I'm going to add this polynomial with this polynomial. Let's combine like terms. Here we go. So 1x to the fourth minus 7x to the fourth, I want to say is -6x to the fourth if my coffee's kicked in. Let me make it in red. Let me keep color coding it. Red with red. So 1x to the fourth minus 7x to the fourth is -6x to the fourth. Cross them out. -3x to the second plus 8x to the second, I want to say is +5x to the second. I'm color coding it. I'm keeping those blue. And then last but not least, the numbers of numbers. 2 plus an 8 makes a 10. Here's my final trinomial after I subtracted them. Nice. Describe the end behavior. Example 3. F of x equals -9x squared plus 3x to the 7th minus 4x to the 5th. How will this function behave at both ends? As x goes to -infinity and as x goes to +infinity. Well, we did that for warm-up. We're going to do one more right now. So right off the bat, I already know I'm going to write f of x. F of x approaches something as x approaches something. Sorry. Hello? F of x approaches something as x approaches -infinity. That's that way. And f of x approaches something as x approaches, look at, as x approaches +infinity. That way. So see, it's either that way and then that way. How does a function behave that way and that way? We get to the door. So how am I going to figure out how f of x behaves on both ends? Well, I'm going to look at the lead coefficient. Look at the lead coefficient.
One's negative, one's positive.
And what's the degree? Okay, lead coefficient, Gabriel, you've been awesome at this. So I'm looking for the highest exponent variable. What's the coefficient of the highest exponent variable? 3, yeah. So it's positive. So lead coefficient is positive. I'll put positive. And what's the degree, Rios? Odd or even? Right, so the highest exponent is odd, so that's a degree. So I'll put odd here. All right, let me look at my notes. Here we go. So I got positive and odd. Look at this. You're gonna have to use this right now with the gallery walk. I'm looking for positive lead coefficient and odd degree. Right here. There it is. So I know the graph will go to negative infinity as x approaches negative infinity, and it'll go to positive infinity as x approaches positive infinity. It's gonna look like that. Just by the lead coefficient and the degree, it tells me that. So here's my answer, this. Let me go back. There we go. Negative infinity, positive infinity. That was easy. I know all this n behavior simply because I know what the lead coefficient is and the degree is. It's pretty astounding how that tells me that.
If it was like smaller.
Hey, oh.
And I paid like the whole
This is for you. This is for you, mister. Your copy. Did he play though?
Y'all go at me on the gram, compa_Juanil.